Good morning students. Today we are going to discuss most important 10 marks topic Schrodinger's time independent wave equation. In exam first we have to present these points, then we have to start derivation part. After explaining these points I am going to start derivation part. A de Broglie named scientist said that a moving particle is associated with wave, and also he named those waves as de Broglie wave or matter waves. And also he told that the wave is having wavelength lambda is equals to h by mv, where m and v are the mass and velocity of the particle. When the particle is having wave properties, then a wave equation can be expected which can describe completely behavior of the particle. Such type of wave equation was given by Schrodinger's, which when it depends on time we call it as Schrodinger's time dependent wave equation. When it doesn't depend on time, then we call it as Schrodinger's time independent wave equation. If we consider this wave as a stationary wave, then the particle is having coordinates x comma y comma z. Psi is a displacement. For de Broglie wave at time t, psi is called as wave function, and psi is assumed as finite, single valued, continuous and periodic. After presenting these points, we are going to start our derivative part. Now we are going to derive wave motion of a particle's classical differential equation can be written like this. Here in this equation, dou square y by dou t square, y is a displacement, where v is a wave velocity, and we can simply write v square del square y, where del square is a Laplacian operator, which is equals to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Here displacement is y, but in de Broglie wave equation phi is the displacement. So in place of y we have to replace phi and we have to write the equation. This is our required classical differential equation. It can also be simply written as dou square phi by dou t square is equals to v square del square phi, can be considered as equation number 1. Here equation 1's solution can be given by psi is equals to psi naught sin omega t. This is considered as equation number 2. If we differentiate this equation 2 times, then we get dou square psi by dou t square. That value we are going to substitute here. Before going to substitute, we have to simplify the term omega, angular frequency, in that value can be replaced. Omega is equals to 2 pi r into frequency. From v is equals to frequency into lambda, we replace frequency is equals to v by lambda. We have to substitute. After substituting and simplifying, d square phi by dt square value we have to substitute here. Now we are going to differentiate twice. Differentiating twice with respect to t, dou phi by dou t is equals to, when we differentiate sin omega t we get phi naught omega cos omega t. For sin omega t we get omega cos omega t. Again we differentiate dou square phi by dou t square is equals to phi naught omega square minus sin omega t. I write this minus here. Psi naught sin omega t, when we see from 2 we can write as psi from 2 is equals to omega square minus psi. Now we have to substitute omega here. Dou square phi by dou t square minus 2 pi frequency square into phi is equals to minus 4 pi square frequency square phi is equals to, in the place of frequency we substitute v by lambda here, minus 4 pi square v square by lambda square into psi. This is the value we are going to substitute here. We consider this value as equation number 3. 3 in 1. So minus 4 pi square v square by lambda square phi is equals to v square del square phi. We are cancelling v square on both sides. We take left hand side terms to right hand side. We write the equation del square phi plus this minus term becomes plus 4 pi square by lambda square phi is equals to 0. Now in this equation de Broglie given lambda value, lambda is equals to h by mv can be substituted. So lambda is equals to therefore h by mv. The lambda in denominator we substitute reciprocally, del square phi plus 4 pi square, lambda we are substituting reciprocally, h square m square v square phi is equals to 0. This is equation number 4. From this equation we have to eliminate m square v square terms. By using this energy is equals to kinetic energy plus potential energy, we eliminate m square v square. Energy is equals to kinetic energy plus v we use. After eliminating m square v square, we get an equation which is called as Schrodinger's time independent wave equation. Total energy is equals to kinetic energy plus potential energy. When we subject kinetic energy is equals to total energy minus potential energy. We know that kinetic energy half mv square is equals to total energy minus potential energy. We have to eliminate m square v square, so we need m, so dividing and multiplying m square v square by 2m is equals to E minus v. We cancel m, we get the same equation. Now we send this 2m to that side, m square v square is equals to 2m into E minus v. This is equation number 5. M square v square value we are going to substitute in 4, from 5 in 4, del square phi plus 4 pi square by h square, m square v square we are substituting 2m into E minus v phi is equals to 0. Multiplying 2 into 4, 8 pi square by h square m E minus v phi is equals to 0. This is equation number 6. This is Schrodinger's time independent wave equation which is in h term. We can represent the equation by substituting h cut is equals to h by 2 pi. We replace h is equals to 2 pi into h cut. After substituting we will get an equation. From that equation we can derive free particles Schrodinger's time independent wave equation. Now we are going to substitute in the place of h is equals to 2 pi h cut del square phi plus 8 pi square by 4 square pi square h cut square m into E minus v phi is equals to 0. 4 1 ja 4 2 ja, phi square gets cancelled, del square phi plus 2 m E minus v by h cut square phi is equals to 0. This is equation number 7. For removing 2m by h cut square in second term, we divide this entire equation with h cut square by 2m. Then this becomes h cut square by 2m del square phi. This 2m by h cut square and h cut square by 2m gets cancelled. We get E minus v into phi is equals to 0. Now we multiply this side into inside. This becomes E phi minus v phi is equals to 0. We send this E psi to that side. This becomes minus E psi. From remaining two terms we are writing psi as common. H cut square by 2m del square minus v. We are taking this minus to this side. This becomes minus h cut square by 2m into del square, minus into minus plus v into phi is equals to E phi. Here this minus multiplies with this term, we get minus here. Here minus into minus, we got plus here. This equation is in the form of h phi is equals to E phi, where h is a Hamiltonian operator, A is energy operator, This term represents Hamiltonian operator. This represents energy operator. For a free particle, the potential energy V is equals to 0. In equation 7, in the place of potential energy, we substitute 0. Then we get del square phi plus 2m by h cut square into E minus 0. So no need to write. So this becomes E phi is equals to 0. This is the equation for free particles. Free particles Schrodinger's time independent wave equation. Equation can be represented as Schrodinger's wave equation of free particles.